In this video I will ramble on about gtick technology, about a certain part, and we will explore the notion of block event delay length, which was I will just show examples to define it. So right here we have a gtick pulse generator, and right here we have a row of pistons. One of them gets powered directly and the other one gets butt powered. And with gtick pulses we have a property that sometimes only a part of these pistons gets powered. And we will define the length of a gtick pulse in block event ticks as the amount of pistons which get activated here. So right here only one of the pistons got activated. Over here we have a different gtick pulse monostable, and if you activate this one, 2 of 3 pistons get activated. So this monostable produces a gtick pulse of 2 block event tick length, while this one produces a pulse of 1 block event tick length. And over here we have another one which produces a pulse of 3 block event tick length, and I will try to explain how this stuff works. So when you right click with lever, you will send a packet to the server, and in the beginning of the next tick the server will process the player request, and this will click the lever and it will update the blocks around it. It will update this whetstone, it will turn on, it will update this whetstone, turn on, it will update these 2 blocks. And they will get tile ticks, and I will use stained glass to represent tile ticks. And the repeater gets processed first, and I will use glasses of different color to represent the order. So white comes before orange, before magenta, and so on. So repeater will be processed first because his tile tick has a priority of -1, while the comparator will have a tile tick priority of 0. And tile ticks with low priority gets processed first. So what will happen after 1 game tick, and it's only 1 game tick of delay because of the lever bug, and you can look it up somewhere else, is that in the tick in which these 2 get processed, first the repeater will get processed, and when he gets processed he will activate, and he will update blocks, and he will update this whetstone, and this will update this whetstone, this whetstone, this whetstone, and this piston will get updated. And when this piston gets updated, he will schedule a block event, and the ticks are named after block events. I will use clay to represent block events. So this one will schedule the first block event, and the only thing which matters in the order in which block events get processed is which one got created first. So this one will get the first block event. Now before we process block events, we first have to process all tile ticks, because block events get processed after tile ticks. So we will process the second tile tick. The comparator will activate, update this piston. This piston will schedule another block event. Now something I should mention is that these 2 pistons don't have block events yet because they haven't been updated yet. Anything. So now all tile ticks have been processed. Now the block events get processed. The first block event which will get processed is this one. This piston will extend, and it will update blocks. It will update this piston, and the piston will see, hey, I'm butt powered, I should get a block event, so I can extend. But before this block event gets processed, this block event gets processed, because this is the second block event. And when this block event gets processed, this piston extends, updates the block, which means this whetstone turns off, this one turns off, this one turns off, this one turns off, and this one turns off. After that, this block event will get processed, but the piston sees, I'm not powered. And if the piston isn't powered, she shouldn't extend. On the other hand, this piston over here already extended, and when the line turns off he gets another block event to retract again and do the gtick stuff, but this piston won't even extend. So in this case, the first piston will extend, and the other pistons will not extend. So now let's look at the second contraction. Over here we again have 2 tile ticks. This one updates first, the whetstone updates, and this one gets the first block event. When this comparator updates, this comparator will not update this piston, but it will only update this piston, so this piston gets the second block event. Now the first piston will extend and update this piston, and I will probably need more clay for this. Now this was the first block event, the second block event gets processed. This piston will update this piston when he gets processed. Then this piston gets processed, because this piston, and now this piston comes before this piston because he has a earlier block event. He will extend, so these 2 actually extended, and now this one gets the fifth block event. When this one gets processed, and he will cut the redstone line, which means that this piston will not extend. These two will extend, but this one won't extend anymore. And then we get that 2 blocks get dropped. And similarly, we have another one where 3 blocks get dropped, so the order looks something like this. This one gets updated, and this one gets updated, and this one gets updated, and this one gets updated, then this one gets updated, and this one gets updated, and I need to get more clay. When this one schedules a block event, and then the thing is cut, and this one won't extend anymore. So here 3 blocks will extend, like that. Now I also made a more general gtick pulse generator, and I need to clean up this stuff. So right here, I will just quickly turn off all the lights. So what happens when we flick the lever is we have a repeater and a comparator here, and when repeater activates, it will activate this piston, and when the comparator activates, it will activate this redstone line, which powers all of these pistons, and you will activate this activator rail, which will update this piston, so this piston will directly get a block event. And then only one of these pistons will drop their block. So like that. Now what this contraption can also do is you can activate this lever. And now things change a little bit, because when this comparator activates, it will activate this activator rail, but it is already activated, so this activator rail won't change its state, and therefore it won't update this piston. So the only way this piston can get updated is through this piston, and this piston gets updated through the rail. So in this case, 2 pistons will drop per block, like that, and now 2 drop per block, and we can add as many lights as we want. Now here something interesting will happen. We have 5 lights and 2 blocks are already extended. So the first 5 pistons will fire, 2 blocks will be retracted, and the other 3 will be extended. So after I flick the lever, you get this. And it's really interesting that you can do these manipulations, because you can get the blocks in any order which you want with this contraption alone, if you have patience. So we can create gtick pulses with any length we want. Now another thing we will take a look at is repeaters which preserve the block event length. So here we had just a gtick pulse generator, which will generate a pulse with 2 block events of length. And I will quickly walk you through this one, because we will then see that here also 2 blocks will be extended, even though we have this interesting contraption in the middle, which is a repeater. So when I flick the lever, the first thing which would activate are these 2. We don't know which one of these activates first, so we will give them the same color. And then this one will get the second block event. Now these 2 get processed, and I will use glass to represent block 36, because when this one activates, he will put a block 36 over here. And when the signal turns on, and I will quickly remove the torch, because otherwise it will be annoying. So these 2 activate, and then the signal can go through here, and then we get the third block event over here, like this. When this block event gets processed, because it's the 4th block event, and I always have exactly not that clay which I need. When the 4th block event gets processed, and updates this one, and when the line gets cut. And when the line gets cut, this piston will still be able to extend, because the line only gets cut here, so these 2 will get block events. But this one will still be able to extend, and this one will schedule another block event. And when these 2 get activated, we will use the sticky piston block dropping behavior, which is when a sticky piston retracts and there's a block 36 2 blocks in front of it, it will replace it with an actual block, and I now can place the torch again. Which means that after these 2 get processed, this line is cut, and this means that this one won't be able to extend anymore, and then we get 2 pistons drop the block, and 2 pistons were also 2 block events were also the input. It does not only preserve 2 block events, but it preserves any block events. I don't have a reset right here, because it's more annoying to explain with a reset, but I build the exact contraption over here again, except that I added another little reset mechanism. Here we can input a 4-block event tick, 0 tick pulse, and it will also be detected as 4-block events, as you can see. And the repeater automatically resets. So we also have a repeater which preserves the block event length of our pulses, which is quite cool. And basically it works for all block events, because when this pulse turns on, the only thing that matters is that this piston will extend and the pulse will turn on. And when this pulse turns off, this piston will drop its block and cut the line again. In both of these operations, dropping the block and extending have one block event of delay of length, so this repeater creates a delay of one block event, but preserves the pulse length. And over here I hooked up the general redstone 0 tick pulse generator to the repeater, so we can see that we can send any pulse through a repeater. So for example, we have 5 block events here, and when we get 5 block events over here, then we can reduce the number to, for example, 3. And then we get again this interesting effect, because 5 blocks were extended and now 3 were retracted, and then we can kind of manipulate everything the way we want. Now we have this. Yeah. So we have a repeater which can preserve the block event length, so we can send these pulses over as long as a distance as we want. Now to other circuits which I want to show, but which I will probably not explain too in depth, are a pulse lengthener and a pulse shortener. So yeah, I will just show them that they work, because I don't want to explain them. I think if you look at them long enough, you might get the idea how they works if you understand the repeater. So for example, here we have 4 lights on, and this one will add another block event tick to the pulse, which means that 5 pistons will extend. So after this, 5 pistons will extend, and then we can kind of have more block events. So we can increase the amount of block events we have from a 0 tick pulse using this special repeater. It also has 1 block event of delay, but it increases the block event length by 1. And over here we have a repeater which will shorten the pulse. So let's just first reset this. So for example, we have 4 block events here, and when we have 3 over there. And what's interesting about this contraption is that if you provide a 1 block event pulse to the shortener, he will completely annihilate the pulse, so nothing will get through, not even a short pulse. So if you do this, there won't be any pulse, not even a 0 tick pulse, which is too short to detect by pistons, because there are pulses which are still 0 tick pulses, but which are too short for pistons. For example, this one over here, it does produce a 0 tick pulse, but pistons can't detect it, but we can still detect it by repeaters. The way this works is this one gets the first tile tick, then this one gets the second tile tick, and then it kind of uses the fact that block events get processed after tile ticks. So when we activate this, first this repeater will activate, schedule a block event here, and this one will get activated, schedule a block event here, and another tile tick over here. And this repeater will then turn on if he has this tile tick, no matter what. And then this piston will cut the power, and then this piston won't extend and will ignore the pulse while the repeater will turn on. Yeah, that's basically everything. Something interesting which I will also show right here is something about comparators. Because comparators, basically when you activate a comparator, it will schedule a tile tick and it won't care what you do at all. And after the tile tick has run out of power, it will check whether there's redstone behind it, and if there is, if the redstone is on, and if it's still on, or if it's on, then it will turn on. Then you can kind of take a 1 tick pulse by using 2 0 tick pulses, so you can kind of have a monostable which comparators can detect, but normal pistons can't, which is kind of cool. Yeah, but I'm going off topic. That's basically everything. Bye.